Welcome to Programming for Cultural Heritage. In this lecture, we're going to talk about loading and reading JSON files. You should probably watch this one after the lecture on loading and reading CSV files. They're very similar concepts. In one, you're working with two different types of data serializations, and the one is a CSV file, and in this one, it's a JSON file. So JSON files are just another type of data serialization or format to transmit data. It's a very similar idea to CSV, but it stands for JavaScript object notation, and it's a very common data serialization standard used to interact with things like web-based APIs and other kind of web-based data sets. So it's often used to represent data that's going to be transmitted on the web, but it's also used for bulk downloads and stuff like that as well. We kind of already know JSON file objects because they're basically identical to Python dictionaries. There might be slight differences in things like capitalization of booleans and stuff like that, but for pretty much everything else, they are identical to Python dictionaries. So if you can think back to working with a Python dictionary, like that class schedule hierarchy, it's pretty much what a JSON structure is. And we'll be using the JSON module to work with it, just the same way we use the CSV module to work with the CSV files. So to work with JSON, basically, you're going to be importing the JSON module, opening the file that has a JSON data in it, similar to you open the CSV file, and then just loading it in using a method built into the JSON module. For us, we're going to be using the JSON load method built into JSON module to load a file. So same idea as how we parse a CSV file. You have to open up the file pointer and pass it over to JSON, and then it will parse it for you. So let's get started. Let's do an example and make a just do a basic load it, make a new JSON file and see how it looks and try to load it. So I'm going to make a new JSON file from scratch. So JSON files are usually, they're dictionaries. And so I'm going to save this as in my downloads folder as a test.json. And so you have key value pairs, right? And so I'm going to say test, and here is the test value. You can also have numbers, right? You can have Boolean variables, but in this case, it has to be true or false. In Python, it's true and false, uppercase, but in JSON, it's true or false, right? Lowercase, T or F. You can have more complex things like something nested, right? You can have another dictionary in here that has, even another nested dictionary all the way down. It's very similar to a Python dictionary or Python dictionary in that you can nest things, have different types of key value pairs, right? All sorts of stuff, right? So if we save this out and we save this as test.json, and so now we want to load this JSON file with our Python script. So I'm going to make a new file and call it load test json.py in my downloads directory. First thing we need to do when we're working with JSON files is import the JSON library. And so now that's imported, we can open up the file that we want and then point it over to the JSON module to parse it. So we'll say with open and then the name of the file, which is test.json. We're going to open it as read. And then we got to store this pointer to this open file in a variable. So we'll say our JSON file, something like that, right? And so now all we need to do is say my data, make a new variable, is equal to json.load, and then pass the pointer to the open file. So once that's done, it should parse this JSON file that we've opened and then store the results in my data. So let's just print it out and see if this whole thing works. So I need to go to my downloads and Python 3, the name of the file is load test.json. right? And so it printed out basically the parsed JSON file. Another thing that's different about JSON is that it uses these double quotes. It has to be double quotations for the key value pairs for strings and stuff like that. Um, and then in Python, it parses it. And Python doesn't care in the dictionary if it's a double quote or single quote. So there's these slight syntactical differences. But if there was something wrong with the JSON file, right? Like it had a bad key name, so this is not a valid key name because it's not a string, and I try to run it, it would say, okay, I can't do this, right? It loads a big error message and says, I was trying to parse this JSON file and I found this weird occurrence on line 4, column 2, right? So it would tell you if the JSON file is poorly formed and not able to be parsed. All right. So now that we have basically, you're able to transport a Python dictionary as a file, or in the future we'll be using APIs. This is basically a Python dictionary. You can send it around using a file, right? And so you can do the same things you can do with a normal Python dictionary. You can do a for loop. So for keys, key name, right? This is just my variable name, whatever I want. But when you loop through a dictionary, you're looping through the keys, right? In my data, print key name. Let's run that. I left my old print statement in there. It's a little confusing. Remove that. Try it again. Right. So I printed test, a number, boolean, nested, right? Because that's the key names in the dictionary, right? If I wanted to print this list of numbers, I would need to say, okay, we'll comment out this for now, the loop. But we'd say print my data brackets. The first key level is nested, right? And then the second key level is nested again. And then the third level is a list, right? So if we ran that, we'd see that it printed out that piece of the data of the list. If I wanted the first one in the list, of course, I'd say index position 0. There it is. Okay, so it's very kind of similar to working with the Python dictionary once you've gone through this part, right? This is the only part that's different. Everything else is pretty much identical to working with the Python dictionary as far as addressing certain pieces of it, looping through and iterating through it, etc. So this is the kind of key point here is you have to open the file and then pass it off to JSON to parse it and do so, and then you can do whatever you wanted to do with it. So I thought we should try, for the challenge this week, you can either do the CSV one or the JSON challenge. But basically, you are going to be trying to parse a big JSON file and do something with it, right? So there's a lot of JSON files around. Some cultural heritage places release their data sets on GitHub as JSON files. Another source is Kaggle.com. It has a bunch of JSON files. So let's go through, if you want to try it on your own first, you can pause the video here and then go give it a try and come back and watch us do it together. Or, if you want to get started off, you can watch our first example of it. So let's take a look at this Kaggle site together and select a data set that would be cool to play with. I came across this one, This American Life. It's like a famous podcast radio show, and so they have this data set has a lot of these Kaggle data sets are for like machine learning training, stuff like that. In this case, this is basically transcripts of the This American Life show. So, they break down speaker, what they said, what part of this, the episode they said it in, et cetera, right? And so if we go through and download this one, it's 861 megabytes. So if you download that, it will download and you'll get a folder if you extract it as a zip file, right? So I just extracted it, and then it extracted into a folder called 811058 underscore number bundle archive. And so if we look in here, there is a number of JSON files, .json files, that's the extension for JSON. There's one called, the biggest one is called train transcripts align.json. So let's make a Python script that opens up this file and does something with it. So I'm going to go back here and make a new Python file. I'm going to save it in the same directory as where I downloaded it and extracted it. So in that 800, 8111058, etc. Folder. So I'm going to say load data.py, right? So now I have a Python script saved in that same directory that the data files are in. And so the only thing I need to do now is make sure I put my, the way I'm doing my running the Python scripts, I just want to navigate to that same folder. It's called 811 something something something. So 81105, 81105, hit tab and it will automatically complete for me. And then I am in that directory. If I ls, I should see those files I was talking about. So there's this big file, 770 megabytes. Let's copy that file name. And then here's my script that I just saved there, right? So let's go back and go to our script here. And if we're going to work with the JSON file, we need to import it, right? So import JSON, the module. Let's say with open and the name of the file. And since this file is in the same directory as the script, I don't need to have any path. I just have the file name dot extension. We're going to open it for read mode, and we're going to save it into a variable called I'll say TTA. That's the abbreviation there. TTA underscore file. All right, so now that the file is loaded into memory, like it's opened up, the pointer to the files exists, we can pass it over to JSON and say, okay, my data is equal to JSON load this open file, right? And let's just see if that works. So I'm going to run the Python script, Python 3 load data. And so this might take a few moments, right? Because it's a 700 megabyte file and it has to open it up and parse it, right? And turn it basically from a JSON file into a Python dictionary so that you can do something with it internally. So that wasn't too bad. It took a few moments there to open it up and load it, but that's pretty cool, right? That's a huge amount of data really, and it is able to do it in a few moments. So we don't really know what's in this file, right? So we could do this a couple of different ways. We could try to open it up in our text editor, but open an 800 megabyte file in our text editor might not work so well, depending on how it's formatted. We could try to use a command line utility, right? So we could try to use less and try to open up that file and see what it looks like in there. So we could do this. And like we could go through and we can see the structure of the file as we move around in there. And then the third possible way, if we didn't want to do that, or if we didn't have access to these command line tools, we could just, once it's open, loop through the keys, right? Because it's going to be a dictionary, right? Once it's turned from the JSON file to a Python dictionary, it's a Python dictionary, and you can do a for loop through its keys, right? So we can say for key name in data, and then print key name, right? So now without having to we don't really know what's in here, but at least by running the scripts now, we would see hopefully all the major key names, or at least the top level key names for the file. Okay, so came back with a bunch of key names, right? And so we can see, and we can kind of read the README file too, but from this we can see that it looks like the script or the JSON file is broken it up into key value pairs, and the top level keys are the names of the episodes, right? So what we could do is make a second for loop, right? For key name in data bracket. We should change this though. So key name, we'll call this data key name, or we'll call this ep key name. actually, let's redo this all. We'll call the top level thing ep number, right? Because that's what the keys are. And then we'll call the next for loop key name. So now we're looping through the data, right? Because we know the key name, so we can reference back to the original piece of data, which is stored in data. And then we'll be getting down to that second level. And so now we should see the second level key names in this big JSON file that we've turned into a Python dictionary. Oh, and it's saying invalid syntax because I did not put a colon at the end of this if for loop. Okay, so now it's opening up, it's looping through each one of those, and each one of those episode keys, it's now going one step further and looping through all the keys that are in that key value pair, right? And so if we, what are we printing? We can always do Control C to break it. And so we can see here that it looks like for each episode key, it's not a dictionary, so we're not looking through the keys, we're looping through a list, right? So it looks like each piece of that list is a fragment from the episode, right? And so now we can see, so some of the keys it has is episode, act title, role, speaker, utterance, start, utterance, end, utterance, right? And so if we wanted to modify our script a little bit better, we know we're not looping through the key names, right? Because we're not looping through another dictionary. We're looping through a list of dictionaries, right? So we'll just call this ep data. So that's a little bit better name for the dictionary. And so since we know that this is the thing we're looping through for each iteration, we can now, and it's a dictionary, so we can now reference a piece of it, right? So we could reference a speaker by using a dictionary, saying speaker, and then we could also print out what they said, right? By looking at this utterance phrase. Okay, so let's try running it again. And so now instead of printing the whole data dictionary for each piece of episode fragment data, it's just printing the person who spoke and then the thing they said, right? So, you could do a whole sorts of things here. Let's just quickly to kind of figure out an example. Let's just look for things where the speaker is Ira Glass, right? So we can write an if statement, and we'll say ep speaker data is equal to Ira Glass. So it'll only get here. He's the host of the show. So it'll only get here if the speaker for utterance. Because it's a dictionary of episodes, and the episodes are broken up into dictionaries of utterances. So if the speaker's Ira Glass, it would only get here. And let's make you wouldn't expect there to be a lot of repetition in speech patterns, right? But we could say, okay, let's make a dictionary Ira talk, and we'll make this an empty dictionary. And let's keep track of how many different phrases there are, right? So we'll say, okay, Ira talk. And so what we can do is we can check to see if the thing that Ira Glass just said, so the utterance, right? So we'll say if is not in Ira talk, then put it in Ira talk, right? So we'll say Ira talk bracket the utterance, or the thing they just said, equals 0, right? And then so now if the thing Ira Glass just said is not in this empty dictionary already, this is very similar to the CSV example we did, then we will make it equal to 0, and then for that same one, or for all of them, if it's there or not, we'll add, if we had to create it or not, we'll add a 1 to it. So we'll say it equals itself plus 1. And so now we're kind of like, we're expecting Ira talk here to be basically a dictionary of phrases that hourglass said, and then the key is the phrase, and the value is the counter, right? So let's just take a look at what if it works and what comes out at the end here. So you imagine there's probably a lot of unique phrases said, right? But then there might be some repetition in them. All right, so very hard to read, right? Because some of these utterances are very long. So what we can do is we basically just created a new dictionary, right? And so what we could do is if we just want to find out some of the ones utterances that were bigger than said more than once or more than 5 times or something, we could just iterate through that new dictionary we created, right? So we want to make sure this is unindented, right? Because we want this IRA talk to be completely populated before we go through it. And so we'll delete this print statement. And we'll say for utterance in IRA talk, right? So now, because the IRA talk is a key value pair, the key is the utterance and the value is the number of times it happened. And so we could say, so utterance is the key. And so we could say, we could make a new variable called utterance count equals IRA talk bracket the utterance, right? So we're kind of just storing this, the count variable into its own little new variable here. And so we could say if utterance count is bigger than 5, print it out. Print the utterance, and then print the word count, and then print the count itself. So it should say like the utterance, the word count, and then the count number. Let's see if it works. Okay, so we can see from these counts, we could go through and find some very common ones, right? So from WBEZ, Chicago, this is American Life, I'm Hourglass, stay with us. So we said that 16 times throughout the corpus, right? And you'd have to remember this doesn't take into account punctuation and capitalization, right? So if WBEZ here was capitalized differently in a different utterance, it would be a different key, right? It's completely very strict on those types of things. So, but so he says, this kind of sign off says 249 times, lots of variations of the sign off. Of course, likes to say things like yes and sure and uh-huh, right? So you could go through, you could actually write you could sort this and see the highest one or something like that. Or you could do more kind of natural language analysis with it. But the key thing is being able to get the data loaded, right? Parsing it with JSON, and then trying to figure out how to navigate the data structure and what's actually in the data structure, right? Because you don't know necessarily from just looking at an 800 megabyte file how it's organized or what the JSON structure is underneath of it. So using this kind of like looping through iteration and seeing what the key names and then seeing what the values are, you can start to find your way through it. But so this is very similar to the CSV. So if you want to do your options, or you could use the CSV, kind of looping through a CSV data set or looping through a JSON data set, do something interesting with the results. And that would be the challenge for this week. All right, so talk to you next time. Thanks. Bye.